So that's the first plot we created. Now we're going to move down to the second line. So if you compare this line of code and this line of code, I'm going to give you a few moments to see if you can spot the difference between those two lines of code before we make the plot. So just take a moment to see if you can see what the difference is. So hopefully you can see that the difference is that x in this case is now CRP null. And in this line it was y. And y is now ID. And in this case it was x. So if we, and everything else is the same. I just left out this data equals, so you don't always have to write data equals my sample. You can just write my sample. R is clever enough to know that that's the data argument will come first. So that change doesn't do anything. The change that does something is swapping around x and y. So I'm sure you can predict what's going to happen. When we run it, you can see that now we have CRP null on the x-axis and ID on the y-axis. If we compare it to the previous plot, you can see that that's what happened. Okay, so this isn't a plot that makes sense. Even this one isn't really a plot that we would ever do. It doesn't really tell us anything because this ID, even though it looks like it's a continuous variable, it's actually just an ID for study participants. So each one of them, you know, because of we have to anonymize them, we don't use their names, we use just we give each one a number, a study number, so that their identity is protected. So that's all it is. It isn't a continuous variable, it's just their ID number. And this is CRP null. CRP is a specific cytokine, and null in this case means we didn't stimulate the samples with any TB antigens. If you remember, if you think back of the study design, you remember that that's part of this experiment. So null just means these are the unstimulated, the CRP produced by unstimulated cells. So this plot isn't very informative. I mean, there are much better ways to show what the CRP null values are in the data, if that's what we wanted to do. But I'm just trying to demonstrate something for you, and that's also why I'm switching the axes in this next plot. So this plot also isn't a plot that we would ever make because it doesn't really, it's not the best plot to show what the data looks like. But I'm making it because I'm leading you towards exactly what a histogram is actually. So here we have another few lines of code. You can see there's a plus sign, a plus sign, a plus sign. So again, this is all one plot, adding different layers. So you can see that up to here, it's the same code as above, but then we're adding something. We're adding something called geom v line. So v here is for vertical line, and we're adding another one. So we're adding two vertical lines basically to this plot. And inside those brackets, we have arguments that helps us to define where we want the line. So x-intercept, so remember intercept is the place where a line crosses an axis. So you might be more familiar with a y-intercept if you've learned something about linear models before, or even high school math. The place where a line crossed the y-axis we called the y-intercept, but obviously you can also have an x-intercept. And so that's what this argument is for, x-intercept 3000, so it should be obvious to you that probably that means there's going to be a line crossing the x-axis at around 3000. We can tell it which color we want it to be, and line type is just, do we want a solid line? We can make a dotted line. So let's run the code and you'll see what happens. So as expected, this is what happens. We have a line crossing at 3000, crossing the x-axis at 3000, and another second line crossing the x-axis at 3500. The line is red and the line type is 2. You can Google line types in R and it will show you 2 is this kind of dotted line, 1 is something else. And sometimes you just want a solid line, so you basically just Google line type R and then you'll get a breakdown of which number you should use. You can also just search it in R's own help function, although I've never done that before. So some of you can test whether that actually helps. I always just Google it. Okay, so why are we doing this? So I'm trying to demonstrate something for you. So if you want to make a plot bigger, you can use the zoom button. So that's going to open the plot in its own window, and then you can look at it a bit better rather than moving this thing up and down the whole time. And you can drag it a little bit bigger and it will reload. So remember we drew these lines at 3000 and at 3500. And what we have on this x-axis is CRP null. So that's a continuous variable in our data. So as you can appreciate, all these dots between these two lines are values between 3000 and 3500, right? And if a dot falls on this side of this line, that means these dots are all less than 3000. And these dots are all more than 3500, but in between here, there are only values between 3000 and 3500. And that's the principle of a histogram, basically. So if you think about this bar that we created here with the two lines we added, we can call this a bin. And you can think about that. It's called a bin because it's, you know, if you think about like a physical bin, like a container, it's as if we're taking all these values and we're putting a few bins. Let's say we decide we want to put it into 5 bins. Then basically we would divide this axis, starting at 0 here and ending at 6000 here. We would divide that axis into equal bins or equal ranges, you know. If you wanted 3, we'd say, okay, everything between 0 and 2000, everything between 2000 and 4000, everything between 4000 and 6000. And we'll create 3 big bins. Okay, so in our case, we created a smaller bin. The range is only 500, from 3000 to 3500. And you can imagine we can create bins. So if we had a line here at 2500, at 2000, at 1500, we can create bins for the data. And inside each bin are only the values inside that 500 range. And that's what a histogram basically does. So it creates equal ranges across the whole range of whatever your continuous variable, however far it goes. And then it counts the number of values in each bin and creates a bar that on the y-axis, in that case, it wouldn't have these IDs like we do, but it just has the count. So if it counts all these values and it finds, okay, this is 100 values, then the bar will be wherever 100 is on this y-axis of a histogram, the bar will be as tall as 100. And then it goes to the next bin, and it counts only the values inside that range of only 500, if that's our bin size. And then it makes a bar again, the height of how many values it found inside that bin specifically. So that's the only reason I'm showing you this plot, because I just want you to physically see what R is doing, or what anyone is doing who makes a histogram. So let's close this window and we go to the next line of code. Now you'll see there are a number of differences. What is the same is we're using the same ggplot function. My sample is the same as there, the object we want to use to make the plot. We have this AES for aesthetic function again. This time we have only one thing in here. If there's only one thing, R interprets it as X equals CRP null. In this case, there is no Y argument for a histogram. We'll see why just now. There's a plus sign because we're going to add another layer. And now here is the big difference. Now we're not going to use a point like before, geom point, but we're going to use geom histogram because that's what we want to make. Bin width is what I just spoke about. If we decide we want our bins to have a range of 500, like we did here with our lines, we can specify that. We say bin width 500, and then R is going to create bins across this whole axis that are 500 wide. Okay, let's run that code and you'll see what happens. So this is exactly what happens, and this is what I explained just now. R created bins from the smallest, this would be the minimum value in our data. As you can see, this point is around there. So it started there with the minimum value, and then it went a bin of 500, 500, 500, 500, 500, and so on. And it took, if the first bin stretched from here to whatever, it counted these dots and it found however many. And as you can see, there were very few dots, so it found less than 10. Inside that bin, then it moves to the next bin, counted the values and plots it on this. As you can see, y-axis is now just the count. So that's just how many dots did it find inside that bin. And that's what a histogram does. And on the x-axis, it's just the same as the previous plot we looked at. That's the actual continuous variable. And on the y-axis, it's the count of how many values you found inside that band or inside that bin.